Good morning. Welcome to Currents Chem World. In this video, we will study what are ideal solutions, real solutions. There are two types of deviations in real solution. They are positive and negative deviations. Why there are deviations? And we will construct vapor pressure composition curves to explain all these phenomena. Okay, let us first study what is ideal solution. Okay, when we mix two liquids A and B, let us mix two liquids A and B, there is no change in the properties of components other than dilution. That is, such a solution is called ideal solution. Okay, when we mix two components, there is no change in the properties of the components on mixing other than dilution. Okay, what are the characteristics of ideal solution? What are the characteristic properties of ideal solution? Delta V mix equal to 0. That is, the total volume is equal to sum of the volumes of each liquid, each component. For example, let us take ethyl alcohol 10 ml, water 10 ml, then Vt equal to Va plus Vb. Okay, so the total volume is equal to the sum of volumes of each component. And then second, no heat is absorbed or evolved. Okay, no heat is absorbed, therefore delta H equal to 0. Third point, no chemical reactions occur between A and B. Fifth point, it obeys Raoult's law, that is, the total pressure is equal to sum of the partial pressures of the component A and B. And sixth point, in ideal solution, all the interactions between A molecules, the interaction between B molecule and AB molecules are equal. Okay. Okay, let us now construct the vapor pressure composition curve for ideal solution. Okay. To construct this, let us consider two liquids A and B, benzene and ethylene chloride. Okay, let us take 250 ml beaker. In 250 ml beaker, first 100 ml of benzene only, and measure the pressure, vapor pressure of benzene only, that is vapor pressure of standard vapor pressure BB naught. Okay, then let us take 90 ml of benzene plus 10 ml of ethylene chloride. For this solution, the partial pressure of benzene only, we are measuring only the partial pressure of benzene, okay, BB. And similarly, 80 ml benzene plus 20 ml ethylene chloride, measure partial pressure likewise. Okay, in the final, 0 ml of benzene plus 100 ml of ethylene chloride, that is, ethylene chloride is pure, therefore it is the vapor pressure of ethylene chloride, that is PE naught. Okay, now using this data, let us plot the vapor pressure composition curve for ideal solution. Okay, let us take benzene, the mole fraction equal to 1, because we have taken pure benzene, therefore there is no ethylene chloride. Let us take benzene, the mole pure benzene here, and the XB equal to 1, mole fraction equal to 1. Okay, and here let us take pure, see this one, let us take pure ethylene chloride, therefore the mole fraction of ethylene chloride equal to 1. Okay, now let us plot this. Okay, let us plot this Let us take vapor pressure in y-axis and mole fraction of ethylene chloride, increasing mole fraction of ethylene chloride in the x-axis. Okay, now let us plot for the data. Okay, you see here initially the vapor pressure of benzene, and as you decrease the concentration of benzene, the vapor pressure decreases. In this mixture, we measure only the partial pressure of benzene only. Okay, so it is decreasing, and when benzene is 0, then there is 0 vapor pressure of benzene. Okay. Similarly, let us take reverse. Okay, let us reverse. We can do it reverse. Then what will happen? This graph is obtained. Okay, first for this PE naught, and then what happens? As ethylene chloride decreases, concentration decreases, the volume decreases, so the vapor pressure also decreases. Okay, this is the Raoult's law to calculate the partial pressure of ethylene chloride and benzene. Okay, now this is the total vapor pressure. Okay, for example, for this, let us take this second. Okay, 90 ml of benzene. So we have measured partial pressure of benzene. Now let us measure the partial pressure of ethylene chloride. Then you plot this. In this plot, we have taken only the partial pressure of benzene. Okay, in this plot, we have taken only the partial pressure of ethylene chloride. This is the total vapor pressure of the solution. That is components A and B. Component A and B, total vapor pressure. So this is the vapor pressure composition curve for ideal solution. We have now constructed the vapor pressure composition curve for ideal solution. Okay, let us now see what are real solution. Real solution means it deviates from Raoult's law depending on the nature of liquids A and B and the temperature. Such solutions are known as real solutions. Solutions which deviate from Raoult's law are called real solution. What are the characteristics of real solution? Heat may be absorbed or evolved. In this case, heat may be absorbed or evolved, heat released. Chemical reaction occur in between them. Okay. Delta V mix not equal to 0, because the property of individual components is not additive. The property of individual component is not additive. It don't follow, it doesn't obey Raoult's law. Therefore, Pt not equal to, the examples are CCl4 cyclohexane, CCl4 and cyclohexane, chloroform and acetone. Okay, so if you look at this, this is polar okay, there are two types of real solutions. Real solutions which exhibit positive deviation. We'll see first. In some liquids, for example A and B, the total pressure is greater than the partial pressures of the individual components. That is, partial pressure, total pressure is greater than the partial pressure of component A plus component B. Okay, what is the reason? For example, benzene and ethanol. Benzene is an aromatic ring molecule. It is an organic molecule, non-polar molecule. Ethanol is having OH group. It is a polar molecule. It's fairly polar. Therefore, there will be repulsion between benzene and ethanol. There will be attraction between ethanol and ethanol because of hydrogen bonding. There will be attraction between benzene and benzene because of hydrophobic interactions. But there will be repulsion between, as a result, the vapor pressure, it escapes the molecules. They hate each other. See, the molecules hate each other, therefore they escape. Therefore, the vapor pressure of benzene of the solution is more than the value predicted by the Raoult's law. Okay. So, as you see, the interactions between A and A is equal to the interaction between B and B, but they are greater. The interaction between A and B is less. Okay, the interaction between A and B is less because of this is aromatic, organic, non-polar, and this is polar. There is repulsion between them. Let us now see negative deviation. There are solutions which shows negative deviation. That in such cases, the total vapor pressure is lower than the partial pressures of the individual liquids A and B. For instance, for example, chloroform and acetone. Here in positive deviation, there is repulsive force between A and B, liquid A molecules and B molecules. Here, there are attractive force due to hydrogen bonding between acetone and chloroform, or salt formation or hydration. As a result, the molecules will not escape, so the vapor pressure decreases. In this case, there are repulsion between the A and B molecules, so the molecules will escape, the vapor pressure increases, therefore the total pressure is more than the value predicted by the Raoult's law. Okay, so in this case, you see the interactions between A and B molecules are greater than AA and BB interactions. The vapor pressure composition curve for real solution can be constructed in a similar way we have earlier constructed for ideal solution. Okay, so let us take A 100%, okay, 100 ml, and then you take 90 ml A, 10 ml B. So what will happen? This curve, okay, this curve will happen. This curve will be given, okay, and now you see this is the expected partial pressure of A. However, there is positive deviation because of repulsion between the A and B molecules. Therefore, there is the total vapor pressure. You see, the vapor pressure is greater than the vapor pressure of A is greater than the predicted vapor pressure of A. Similarly, let us take pure B, okay, pure B, and then you add 90 ml B, 10 ml A. So you will get this graph, you will get this line, and okay, so because of repulsion between the A and B molecules, the vapor pressure of B is greater than it is predicted based on Raoult's law. Therefore, the total vapor, you see here, this is the predicted and this is the observed. The total vapor pressure of solution is greater than the sum of the partial pressures of the component A and B. For negative deviation, you see here there is a downward, and that is it is downward, and this is downward. So the total vapor pressure of the solution is less than the partial pressure, less than the Raoult's law predicted vapor pressure, total vapor pressure. Okay. Thank you for watching. Please share and subscribe. Thank you again.